In example number 5, we're asked to differentiate the following. Okay, so our first one, part A, asks us to differentiate the natural log of 3x. Now we don't know a direct formula for the natural log of 3x, so what we're going to do is we're going to let u be equal to 3x. And so then this becomes the natural log of u. So what we want to do is we want to differentiate this. So let's go one step further. So this implies that d dx of the natural log of u, that's equal to d dx. Oops, let's change this. So I'm going to replace d dx. So let's go du dx times d du of the natural log of u. So let's get du dx, this guy right here. So we get it from over here. So the rate of change of u with respect to x is 3. So that's this guy. Now we have to multiply it by d du of the natural log of u. And we know that that is 1 over u. And so this is going to be 3 over u, which is 3x. And so that'll become just 1 over x, because the 3's will cancel out. You know what's interesting about this is the natural log, the derivative of the natural log, no matter what number you put right here with multiplication, it'll always be 1 over x. Just think about that. Now, of course, we again make the assumption here that x, that this guy right here, well, 3x in this case, okay, has to be greater than 0 or positive. So let's go ahead and work on b. So b is xe to the x times the natural log of x. You know, one thing that I didn't say, and actually I want to point out before I do that. One thing that I didn't say is that when you have the natural log of x, the natural log of 3x, we can rewrite that as the natural log of 3 plus the natural log of x. And the derivative of the natural log of 3 is 0, because this is just a number, plus the derivative of the natural log of x is 1 over x. And so that also gives us just 1 over x. Now this isn't as, it's nice. I mean, it works real slick, okay, and it gives you the right answer. And of course it follows all of our rules here. There's nothing wrong with that. But what's going on here is we're not seeing that chain rule come out, and it's nice to have practice with that. But you can do it this way as well. So when you're working with logs, you may want to try pulling out some of the different forms, using your different formulas for logs so that you can rewrite them, and it might make your differentiation a little bit easier. So here we've got xe raised to the x times the natural log of x, and we want the derivative. So we'll do d dx of xe to the x times the natural log of x. And now what we've got here, we've got a couple different things that we can do with this. Okay. What I'm going to refrain from is trying to combine this guy and this guy together. But I've got 3 different guys here, so I'm going to go ahead and I'm going to use the product rule. So this, and I'm going to leave myself some room here, this is the derivative of the first times the second plus the derivative of the second guy. Now, what am I calling first and second? This guy is my first. This guy is my second. Now notice that's 2 functions too, so I'm going to have to play around with that a little bit. So this will be e to the x times the natural log of x, like that. So this guy's not bad. d dx of x is 1, so I just get e to the x natural log of x plus. Now the derivative of this guy, you know, if you do it slowly and you do it in steps. You can always get these answers. It's when you try to start doing stuff in your head, you're going to mess up. So the derivative of this, that's the product rule again. So d dx of the first guy times the second guy plus d dx of the second guy times the first guy. So this is still e to the x natural log of x plus. Now d dx of e to the x we know is e to the x. So clearly this just stays the same. Plus, now d dx of the natural log of x is 1 over x times e to the x. So we can try to put everything with a common denominator here. Hang on one second. Right up here I forgot to, when I took the derivative of the first times the second plus the derivative of the second, I forgot to multiply it by the first. So this whole guy needs to get multiplied by x. So that means this whole guy needs to get multiplied by x. There we go. That looks better. So e to the x natural log of x plus x e to the x natural log of x plus now x over x. As long as x is not 0, that's good, where it's equal to 1. If x is 0, well, we know x can't be 0 because of this restriction right here. So this will just give us e to the x, just like that. Okay, now let's go ahead and work on c. So c says let's take 8 times the log base 3 of 8x. Now I'm going to work on this 2 different ways. Okay, so way number 1 is to go ahead and do the derivative. Okay, so let's go ahead and do a substitution here. Okay, so let's let u be equal to 8x. So what I've got then is d dx of 8 times log base 3 8x, like that. We can pull the 8 out, so that's one of our rules. So we get this. And we're going to replace the 8x with u. But now, I don't want to differentiate with respect to x, I want to differentiate with respect to u. So chain rule is going to give me 8 times du dx times d du of log base 3 of u. Okay, so that now, well, du dx is 8. Okay, right? Take the derivative of this with respect to x, we get 8. So what I have is 8 times 8 times. Now, d du of log base 3 of u is 1 over the natural log of 3 times u. Okay, and so this is equal to 64 times 1 over the natural log of 3 times, now u is 8x. So this gives me 64 over 8 times the natural log of 3 times x, which gives me 8 over the natural log of 3 times x, like that. Now that's one approach. The other approach would be to use a change of base formula in here. So if we had 8 log base 3 8x, we could use a change of base and say that this is 8 natural log 8x. Excuse me, hang on one second. Excuse me, let me erase this right here. This is the natural log of 8x over the natural log of 3, like that. And we know the natural log, so d dx of this guy, I can put 8 over the natural log of 3 and multiply that by the natural log of 8x. So this is just a number, so let's pull that out. So that'll be 8 over the natural log of 3 times d dx of the natural log of 8x. And we just went through up here that the natural log of anything times x is 1 over x. So this guy right here is equal to 8 over the natural log of 3 times 1 over x. Excuse me, 1 over x, like that. Okay, so that'll give me 8 over the natural log of 3 times x. Again, it gives me the same result.